Okay, here we go. So today we're going to be graphing all the other trig functions. Okay, so we've done sine, done cosine, done tangent. We're going to do secant, cosecant, and cotangent. And to get us prepared for that, you're going to come up with the values as you go around the unit circle for those. Now, please note that this sheet, this is like your big table of values, your reference page. Note that the sheet goes 0, radians, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. If you think of a unit circle, we have just named the first half of it. Yeah, there's 0. There's your pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. We have named all those points using this. Okay, now obviously this is the second half. I hope that that's evident then. Okay, also note that I should give credit to Vogel. Vogel did this a long time ago, but he put these in order. So all your sixths are here, and some of those 6 reduces to thirds. All your fourths are here, and all your halves are in this column. There's actually, if you want to think of columns there. Okay? What you're being asked to do is to find the value of sine when theta equals this. So for instance, if you think once again to your unit circle, I should get in the habit of actually drawing the circle before the axes. You'd think I'd be better at doing that. But okay, you think of the unit circle, theta is 0 right here at standard position. Okay, the coordinate of that is it's 1, 0. And recall that 1, 0, the 1 represents cosine, and 0 represents sine. Okay, so for 0, sine is 0. When theta is 0, sine is 0. Cosine of 0 is 1. So remember, this one is y. This is x. Your y coordinate and your x coordinate in the unit circle. What is tangent? Tangent is sine over cosine, or y over x. So 0 over 1, which is 0. That was not the resounding 0 I wanted to hear. So remember, when you're there's two things. You have 0 over 1, or you could have 1 over 0. One of those gives you 0, the other gives you undefined. If the 0 is under the fraction bar, it is undefined. Okay? If it's over the fraction bar, it is 0. Okay? I know. For those of you who are like, that's so stupid, but I couldn't remember it, well, then it doesn't seem so stupid anymore, right? So use that. Now maybe you'll remember it. Okay? That's okay to have silly little tricks you use to remember things. Okay? All right. Now, cosecant. Cosecant is the reciprocal of which of these? It's the reciprocal of sine, so it's 1 over sine, which is the same thing as 1 over y, which is 1 over 0, which is undefined. Undefined. See how resounding that was? That was great. Okay. Secant is 1 over cosine, which is 1 over x, which is 1 over 1, or 1. A lot of 1s. Okay. And cotangent is cosine over sine, or x over y, which is the reciprocal of tangent. The reciprocal of 0 is undefined. Now, just for fun, we threw in how many degrees is this? 0 degrees. That's just fun. Okay? All right. So you're going from 0 degrees all the way to 360 degrees down here at 2 pi. I will tell you, as you progress around or progress down this page, you should start seeing patterns, which means you should not have to do math for every single one of these. Remember, there are patterns when you move around the unit circle. Right here at 30 degrees or pi over 6 radians, we're at root 3 over 2, 1/2. X is root 3 over 2. Y is 1/2. Okay, that is the same value as this one over here, just with signs flipped. Not sign necessarily flipped, but symbols. One's positive, one negative. Remember, you have a positive-positive relationship in this quadrant. Okay? So this point right here, there's going to be another point just like it down here, and another one over here like it, and one over here like it. Okay? So you should not have to be calculating all these. Remember, it's periodic. There are different patterns that you're going to see. Okay? Questions? Your job's to fill out that entire table. Off you go. In exact form, no decimal form yet. Hey, I realize you're not all done. However, I also know that some of you are pretty close to being at where pi is. Okay, I know that we're not all working necessarily this way. You may be working down the page. But I'm going to do a little math here just to make sure. Okay, stay with me, please. Just to make sure that everyone understands what you're doing fraction-wise. So y over x, 1/2 divided by root 3 over 2. Or the other way of writing is 1/2 times the reciprocal, which is 2 over root 3. Okay? So you get 1 over root 3, which is equal to root 3 over 3 when you rationalize it. Okay, so for those of you that just said in your head, what is rationalized? That would be a huge concern. However, it's when you multiply by the radical over itself, right? Root 3 over root 3. Okay, that special number 1 there. That gives you root 3 over 3, root 9, which is 3. Okay? So, that right there, good to go? How many got that one? All right. So, pi over 4. No, actually, let's do all these. So 1 over y is 2. We just flip it. We flip this one. That's 2 over root 3, which is 2 root 3 over 3. Okay? This one's flipped, which, by the way, if you have to flip something that you've rationalized, then flip it back before you rationalized it. So take that. That's the reciprocal of it. So that one's just root 3. Okay? Remember, when you're going around a unit circle, can I borrow your unit circle for a minute, please? When you're going around a unit circle, at pi over 6 right there, pi over 6 right here is the same as these values over here. So if you go to 5 pi over 6, they're the same values, it's just that x is negative. So when I go over to 5 pi over 6, right here, x is negative. So it's negative 3 root 2, or negative root 3 over 2, and 1/2. And if x is negative and I'm doing y divided by x, that means tangent is also negative. So it's negative root 3 over 3. 1 over y isn't changed. However, 1 over x is now negative also. And y over x is also negative. Okay, so we should have our negative symbol there. Then you rotate them. Good. Nice work. Okay, pi over 4 on your unit circle. I appreciate you letting me borrow your unit circle. Root 2 over 2. And they're both root 2 over 2. So the tangent is x divided by y are 1. 1 over y, thank you. 1 over y, we flip it, so that's 2 root 2 over 2, which is just root 2. This is also root 2, and this is also 1. Okay, now if we go back to the unit circle, which Tyler so happily let me borrow. Thank you, Tyler. Okay, root 2 over 2, that's this value here. All right, so that's our negative. Okay, so we now have x's are negative here. So we come down to this side, that's 3 pi over 4. This is a negative. And does the 1 change to negative? Yeah, because it's y over x. So this one's negative. Well, positive divided by negative is negative. Negative 1. Does cosecant turn to negative? Nope. Does secant? Yes. Does cotangent? Yes. Oops, just negative 1. All right, now for those of you who are like, oh, I'm kind of getting that, well, you could have also, you could have done this with the 30 as well. We could have dropped down to this quadrant. But you could also take the 45 and drop it down here to 7 pi over 4. Which one turns negative now? The y. All the values are the same, it's just y is now negative. So when you go down to 7 pi over 4, okay, you're dealing with the exact same coordinates as 3 pi over 4 and pi over 4. It's just now, see if I can get them all on the screen there. It's just now y is negative. Okay, so this is negative root 2 over 2. This is positive root 2 over 2. Tangent is still negative because one of those is negative. Root 2 is negative. Secant, or cosecant, the root 2 for cosecant is negative. The root 2 for secant is positive because x is now positive. And cotangent is still negative. The other value of pi over 4 is right here at 5 pi over 4. Remember, you're in quadrant 3 at this point, so if you're looking at your unit circle, you're down here. You're looking for this point, which means you're in negative, negative, so everything, or all your x values are negative. All your y values are negative, which means when you divide y by x, you get positive. And when you take the reciprocal of a negative, you still get a negative. So everything's negative except for tangent. And is cotangent negative? No, because negative divided by negative still, it's still positive there. Okay, so we've got our 45. We have our 135. We have 225. And we have 315. Okay, now you could have done the same thing for this 30-degree one, right? It corresponds to the 150. It also corresponds to, well, if you think of a 30-degree reference angle here, that would be right here. So it corresponds to 210 and to 330. So if I go to 210, which is my 7 pi over 6, let me see where we got that here. Okay, and my 330, which is my 11 pi over 6, those are going to be the same values as my pi over 6. It's just the signs are changing. Okay, and the same thing happens with your 60 degrees and your 90 degrees. So I hope I've made it a little easier for some of you that are struggling on getting these. Okay, you get about 4 more minutes to do your best to finish. Okay. Okay, I'm going to have you check your work. I'll put up a key up here. You just kind of check through. I know that most of you are kind of wrapping up, but let's get the first half of the table up there. Okay, notice I highlighted the 0, 45, 90, or 0, pi over 2, pi. And I've also got 3 pi over 2, or 270, and 2 pi, which is 360 highlighted. But check those. See how you make sure you match up, because we're going to use this here in a minute. There's certain patterns that are happening, and obviously a lot of different numbers that continually appear. I'm going to go ahead and move that so that you can kind of look at the bottom, John. Some of the top part's still on there. Hey, if you haven't quite finished, you can wrap that part up later. We definitely need the top part of the table, and there are a few things we need to find. First, I want you to find the decimal equivalent of root 3 over 2. The decimal equivalent, so let's list some of these over here. The decimal equivalent of root 2. Let's go to the nearest tenth. Root 3. What's that? Oh, I'm sorry. I've got them off to the side over there. Let's put them, we'll put them over here. So root 2, root 3. What else do we have here? Let's go root 3 over 3. Root 3 over 2. 2 root 3 over 3. And root 2 over 2. Those are all the different fractions that are irrational. I want you to find all those values, please. Yeah, let's go out to the nearest tenth. Those are the ones that continually repeat themselves. Okay, so do we have a value for root 2? 1.4. Okay. How about root 3? 1.7. How about root 3 over 3? 0.6. Okay. How about root 3 over 2? 0.9. How about 2 root 3 over 3? 1.2. And root 2 over 2? Okay, there we've got them. Okay, we're going to use those as we're graphing here. So I now need you to take the other page you picked up on the way in. You've already created your table of values. We're going to go ahead and relate sine to cosecant. Okay? Please note a few different things on this graph. First, I'm asking you to graph two things. The first thing we will graph before we graph cosecant is its reciprocal value, sine. That is what we'll always do anytime you're graphing the reciprocals. You'll at least plot points for sine. Okay? Also, take a look at the grid. I have defined your scale. You have not done any graphs like that yet, whereby I've actually said you are going up by a specific amount. So as you're doing sine, remember our little phrase we used was 0. Good. 0 max, 0 min, 0. Okay? Now, we know what our maximum is. It's our A term. So our max is 1. We know our min is -1. We know 0 is at 0 on the y-axis. I mean, it's not like we're hiding anything there. However, in terms of the theta axis here, the theta axis, this 0 is at 0. This 0 and this 0, where are they located? Where's this one located? No, the end one. That would be at 2 pi. We're graphing from 0 to 2 pi. There's only one cycle here, right? Okay, b is 1. So 0, if that's 2 pi, what's this one? Pi. That means when I'm going here, there's 1 0. My other 0, my next one's at pi. And the last one's at 2 pi, which is right there. So I plotted my zeros. I then can plot my max and min. I take halfway between my zeros. Right there. that's my max. Right here, that's my min. Notice I'm not going every single line is one of these now. That's more realistic of the way you'll graph it. I mean, the way we were doing was very elementary in the way we were doing it. You're now doing it more high school. Good news, you skip middle school. Nice job. Okay? That's very good. So, we go from here. We've got our graph. Remember, we only see one cycle from 0 to 2 pi. Tell your neighbor why. How do we know that? Yes, B is 1. So for those of you who started out by actually listing A, B, number of cycles, they're the same here. And then the period. Period is pi over B, or excuse me, 2 pi over B, which is just 2 pi. It's a good strategy to use, just like we've done on all of them. Okay, and you could even check yourself. You could go, okay, hold on, I've got a big table of values. Let's make sure I was right on sine. Yep, at 0, I'm at 0. Good. At pi over 6, well, that's right here. Right? 1, 2, 3, 4, 5, 6. So pi over 6, I'm at 1/2. Okay, perfect. Man, I didn't even put that point. And then, okay, we could actually check all that. Okay, the reason we have this table of values, though, is we're going to graph cosecant now. So I want you, we know that this is pi over 6 right here. We know that because, tell your neighbor how you know it. Okay, pi is here. Divide pi into 6 lines, pi over 6. Okay, so let's go to cosecant. Cosecant at pi over 6 is 2. So we go on here, we plot 2. Okay? We now go to the next one. What's after pi over 6? Well, it's 2 pi over 6, which is pi over 3. Pi over 3 for secant, or cosecant. 2 or 3 over 3, which we know as 1.2. So we're going to go here. Pi over 3, 1.2-ish. The next one is pi over 2. Pi over 2 is, it's 1. Okay, it's right there. It's that exact same point. And then if we do the next one is 2 pi over 3, which happens to be 2 pi over 3 is the same value as pi over 3 for cosecant. So it's 1.2. And how about 5 pi over 6? Pi over 6 is 2. Okay? So we plot our 2. And then the last thing right now is pi. Pi is what? Undefined. Tell your neighbor why pi is undefined and what that looks like as a graph. What's up? Why is pi undefined? Yeah, it's 0 right here. Okay? The reciprocal of sine is cosecant. That means it's 1 over sine. That means when sine is 0, it's undefined for cosecant. It's 1 over 0, which is an asymptote on a graph. That means every place you see a 0 on a sine graph, the cosecant is an asymptote. Now we're going to pick up the pace a bit here just so we get this done. This is a branch. Please note that that branch never stops moving upward. Therefore, there is not an amplitude here. Okay, it's just a U shape right there, kind of parabolic type looking thing. Okay, this right here, you'll note that if I do the next point, which this is 7 pi over 6, you would find that 7 pi over 6, if you start looking at your table, that is -2. So you start repeating these same points that we had over here. up here. So this is now negative 2, negative 1.2, negative 1.2, and negative 2, just like this was 1.2, 1.2, 2, and 2. And there's that. So your cosecant graph, all they are just these little horseshoe-looking things off of your sine curve. Now, you do not actually include the sine curve as part of your graph. When you're done using it, you erase it. That is your cosecant graph.
Do you do this every time?
Yeah, every time, man. You're welcome. Yep. Hey, now if you want to keep both of them on here for note's sake and just highlight, you can. But it's up to you. Okay? Any questions? Cosine. Cosine is what type of shift of sine? If we slide our sine graph 90 degrees one way or the other, okay, so remember cosine, we go max, 0, min, 0, max. So we're just moving our points over. Okay, so if I go with cosine, my max is at 1, my min is at negative 1, and then my final max is at 1 as well. Well, I know I start here. How many in the parent function, how many cycles will I have? I'll have 1. The number of cycles is 1. The period is 2 pi. Okay? Which means this is at 0. The end of this graph is at 2 pi. The middle of the graph then is at pi, which means I have a minimum at pi. And then I have my last maximum at 2 pi. And in between there, I have my zeros. We graph our cosine curve. Once again, you could check it using a table of values that we created, but to graph secant off this, if we know secant is 1 over cosine, when are you going to have undefined? Yeah, when cosine 0. So all these places where you see the graph hitting 0, that's going to become an asymptote. What do you think is going to happen off these peaks and valleys? You get those little horseshoe-looking things, right? The same numbers for secant, just note they're shifted. Okay? So we get, at pi over 6, we get 2 root 3 over 3, which is 1.2. At pi over 3, we get 2. So notice these are just transposed there. So you have a shape going up like that. Down here you're going to have negative 2, 1.2, or negative 1.2, and negative 2. And then 1.2 and 2. Oops. That is your secant graph. If it helps, some of you may actually just highlight that just for your note. Those are your asymptotes. Okay? The highlighted part is your secant. I like to think of it as secant. Yes, I can. Yeah. Maybe positive about it. Okay, any questions? Everyone rate themselves 1 to 5 right now. Where are we at? Close? Okay. Ask your neighbor, what's the biggest thing they're struggling with right now? All right. Can I have your attention back up here? If you could not help your neighbor out a bit, or if you didn't have an answer maybe to help them, what are some of the questions? What's that? Oh, you didn't have enough time? All right, go ahead and keep talking then. Now, any questions now? Try to circulate and ask. Hey guys, I did have a few of you talk about the speed, like you're going fast, McCoy. Guys, I have to keep the pace up a bit in order to get us through the material. And then remember, there are a variety of levels, and some of you are picking it up a little faster than others. Okay? I promise you, though, that I'm trying to build it. I built 3 days in for 9-5 for us to practice the material. Okay? So once we have it down, we'll have plenty of time to practice it. Okay? Let's look at tangent. Turn the page, flip it over. Tangent, our pattern for tangent is 0, A, asymptote. I know I always struggle with abbreviating asymptote, so we're going to use S. Okay, and next one, negative A, and then 0. Okay, so using this, in third period we kind of messed up. So let's fill this out. A is what? 1. B is 1. Here's where we messed up. Number of cycles is 2. It's always twice as many. Now when you're going between sine and cosine and tangent, and in sine and cosine, the number of cycles in B are the same. In tangent, it's always twice B. Okay? And the period is pi over B, which is just pi. That means I am going to see 2 cycles of this graph, which means my first 0 is right here at actually 0 on the theta axis. My last 0 is actually at pi, which means the asymptote is at pi over 2. So 0, 0, halfway is my asymptote. We good there? Okay, the A term is 1, and negative A is negative 1. So we get 1, and that's halfway. Whoops, make sure we put it halfway. So that'll be right there. And then halfway between the asymptote and the 0 is negative 1. Okay, and so if we're going out to 2 pi, this is going to be 2 pi right here. That's going to be our last 0. Halfway in between that is our asymptote again. Then we have our A and our negative A. And so, what's that? Yeah. So our tangent curve, we get our 2 cycles right there. Now cotangent, remember cotangent is 1 over tan, which means wherever tangent is 0, you're going to have an asymptote. Which, you guys, this graph, I promise you here in a minute, when you put all these asymptotes in, you're going to be going, you've got to be kidding me. What a mess. Okay? So you can see the shift, you can see the graph here now. Wherever I had a 0, it's an asymptote. Right? Because the reciprocal of 0 is undefined. Well, what's the reciprocal of undefined where there were asymptotes? 0. So wherever there were asymptotes, it's now 0. Okay, and if you were to reference your table, you would find out, this is pi over 2 right here. You would find out that pi over 4 has a cotangent value of 1, which is this same point. It shares that point with tangent. And it shares that point. And it shares that and that. So cotangent, you just change your zeros to asymptotes, your asymptotes to zeros, and you keep the same a terms, and that is your cotangent graph. Kind of. Yep. To summarize, on all our graphs, on all the reciprocal functions, the common thread, all zeros become what? Asymptotes. All asymptotes that you had become zeros, and what one value do the sine cosecant, cosine secant, and tangent and cotangent, what do they always have in common? There's one coordinate. What is it? Yeah, they always share the a term. Always. On all of your graphs, they shared the a terms. That was your common thread. Okay, I need you to take your assignment from last night. Okay, page 266 of your student journal. I have, now what I asked you to do, 1 and 2 should have been easy. Those were tangent graphs. Okay, everyone's back right here. I asked you on all of these to graph, if this was cotangent, I asked you to graph the tan. You should now be able to quickly go, oh, well, cotangent is just tan, that becomes 0, that becomes 0, this becomes asymptote, this becomes asymptote, and they share a. You now have cotangent. You may not have graphed it quite as far there, but that's now cotangent. You would obviously want to erase the tangent lines. Okay, if you're doing 5 with secant, here it is. Asymptote, asymptote. At all your zeros you have asymptotes. And at the peaks you have a U-shaped. Now, as long as you actually draw a U-shaped, I'm fine that you're not calculating the values in between right now. If you start drawing big looking V-shapes or getting really all messy with it, then I'm going to make you calculate those other little values there. There is secant. Obviously without the sine curve, or the cosine curve there. The same thing happens with cosecant. All your zeros become asymptotes. That's getting a little pointy on that one.